Welcome back to Docs Off Topic. So behind me you can hear the very loud power hacksaw. I don't use it much since I got the chop saw, but I've got nothing that fits what I'm cutting, so yeah, bear with me. So for the current project, I'm going to need some additional tooling, mainly because I need to work on that threaded rod behind me. Let's see if I can show it to you. That is some 42mm 4 TPI actual square thread. And what I need to do for the end, for what I'm doing, is make a split nut that goes in the pressure plate, for which I need a die holder for that die. That is an M45 by 4.5 for the outside of the split nut. I will be single pointing that as close as I can get it. It's metric. Both my lathes are Imperial. And we'll see how close we can get. The other thing I will need, I should have put that somewhere else, is a tap wrench, because I need to cut the mating thread for that split nut. Pretty sure that is 1 inch. The die is 90mm, or just shy of 4 inches, so what, 4 1/4 inches, something like that. Pretty sure that's 25mm. Yeah, 25mm. So I need a really big tap wrench. It's probably going to be on the order of 3 feet end to end. It's a good thing I've got lots and lots of 1 inch 4140 and some 1 inch plate. So let's get cracking and let's have some fun. First chips. So we're getting a little bit of flex in the tailstock. I think the clamp plate needs to be bigger. Or possibly we need to scrape the bottom of the tailstock flat. This is going to take a little while, so I'll bring you back when we're a bit further along. So right now I'm taking advantage of the fact that I'm turning a long straight piece to run in the tailstock to get it perfectly aligned. it was out by about 0.3 millimeters at this distance. So I'm going to true it up, see how that goes, and then at some point in the near future we'll run between sanders. But right now I need to get these things done. And over here we've begun truing in the billets that will become the die holder itself. Trying to keep the forces as much in line with the vice jaws as I can to minimize chatter. This is not the ideal setup, but I need one edge I can bank on. So we're just truing up side 3 of 4. Turns out we're at 62 degrees. So I've used my Mitutoyo protractor to set the angle against this face here. Unfortunately, we're going to end up a little bit under on these two faces. And that's purely because of what I had available to set up for cutting. Hopefully I don't need to take too much off the side. You know, the handles for this are very much like the offsets that I made in the last video. So I'll let you comment after that. It's a good project in the project value. Alright, so this is the last of the major sides. Right. Oh, there's a storm rolling in. Okay, let's get the other one to this stage, and then we'll call it a day. Okay, so we're set up to mill the mating surface, so this is going to be inside the welded area. We just need to get it flat, get rid of these divots and whatnot. Is this the best setup for holding it? I don't know, probably not. I'm hoping that, considering I'm only taking a 0.5 millimeter cut, it's probably going to be okay. Alright, so, I don't suppose it matters which way I go. Trying to decide, do I give it a bit of coolant? It's going to be boring. I'll bring it back when it's done and probably ready to weld. Okay, I probably should have gotten that on video. But that's the first arm ready to put into place. The body is still cooling off in my annealing bucket. So I've nailed the outside just to give it a bit of, grippiness. These are going to be set like Mawson tenons in about 45 mil, and then I'm going to weld around the outside. I'm not sure if that's the best idea, but it's the idea I've come up with, and I'm sticking with it. Alright, let's make number 2. So what I've noticed is that whilst it looks like there's a fair bit of run out in everything, the bulk of it is actually in the chuck. The chuck has got a lot of run out. The way it's mounted is not very concentric at all. So I am going to go ahead with my initial plan to make a D14 cam lock for it, with the bulk of the work being done with everything mounted on axis so it doesn't come off. And it is truly concentric with the spindle. The way this thing is set up at the moment, there's a lot of ifing and butting about how accurate that is. I don't think the taper it registers on matches well. Anyway, let's turn up handle number 2. These don't need to be super precise, they just need to be clean and look reasonable. This thing's going to get used once and then probably hung on the wall forever. You watched the beginnings of this when I did the other one. That's the same. I'll try and catch the knurling this time when I get to that part. Alright, let's bring this thing down to 23. Ooh, that's got a noticeable bow in it. Bow or where? Oh, It really is a great feeling. It's like 5 years of hard work, and now we're doing what it's doing what it's supposed to have always been able to do. So 40 units gave us a 0.8 of a millimetre depth of cut, or off the diameter. So I'm doing 5 at the moment. And I'm hoping that leaves me at 19.3-ish. $19.25. Gonna be the dodgiest bit of knurling ever. And I say that because this is slightly out of round because I screwed up. And short of making it markedly shorter than the other one, I can't really fix it. If I'd been a little bit more on the ball when I made the blanks, I would have only pre-drilled one end. But I didn't think that far ahead, unfortunately. Okay. Oh. Fair bit of friction there. Yeah, it's a bit dodgy there. But, yeah. It knurled. that's the handles ready. Well, let's work on the body. Okay. Half a millimetre depth of cut. See how we go. This is the most pitted side. Still makes you watch still we can't let it just hold it for a long time. Look at my field, really. I can see a line, but I cannot feel it, so it's less than 20 microns in height, which, to be fair for this application, more than adequate. Alright, now we're going to do that, splatter removal and set it up. The aim here is to deck that off to one level, do it opposite, and then we'll cut these two to 60 degrees, those to 30 degrees, and then we should have it nice and square. I have some measurement marks remaining on this side, which is why I haven't done that side to flat. And then once we've got those cardinal sides done, we'll grind the radius. And then set up to do the ends. Somewhere along the line we've got to poke a big hole through the middle. Celsius, which means in the shed it's probably closer to 40-45. we find out how porous my welds are. So we're taking 0.125 of a millimetre, because we are right on the cusp of clean up. Still have half of our dots on that side remaining, which is ideal. Only unknown is, will we clean up the far side for the entire length? Alright, that I can live with. Most of that corner is going to cut out and be chamfered out. That's pretty good. Almost got to the bottom of that divot. Oh no, there was a bit of a flame cut corner there. And I filled it in with some weld. I didn't quite get all the way to the bottom. Okay, flip it over. So we've got two parallels. And then after that, we set these to 60 degrees to the table. And then that gives us a regular-ish hexagon. So I've got this set to 60 degrees. And I'm just checking to make sure that we are still at 60. And as close as I can tell, that is pretty much it. It's within probably half or quarter of a degree, which for this application is way better than it needs to be. Okay, we have to go up. This is going to be, that's our high spot there. Once we've got this down, then we'll make that one parallel, but we'll also make sure that this to this distance is the same as this to this distance. Means I've got to establish that now. Okay, 121.8. Okay, gotta go up. Okay, now I'm just worried that this might actually be our high spot. Yeah, I think that might actually be it. Let's do this. This will take a little while. I'll bring you back when we're nearly done. That's our final pass. We do have some porosity in this weld, but it should be fine, considering what it's being used for. Alright, next job, let's poke some holes in this. Need to get as much of that hole done as I can. Should clear that block. So, does it need to be 100% accurate? No. Sure helps. Okay. Not that I really need to. Okay. I'm going to spot drill. I'm going to pilot drill. I think it's 1/4 inch. 1/4 inch, so that this thing doesn't actually have to do any drilling. And yes, I'm going to use a hole saw because I want to remove as much metal as I can without wasting too much, and the biscuits will always be of some use somewhere. Okay. I'm going to move you where my big fat arm doesn't get in the way. This is where bad ideas are born. disc is out. Let's start on the next one. Should be a bit easier because now the swarf's got less distance to travel. It's got somewhere to go. And go down. And that's it, we're through. That was not fun. Hashtag don't do that at home. Okay. Let's square off the end. Because this is weld and there might be a little bit of slag along the way, I'm using a chipped and damaged cutter. So I'm not expecting the best surface finish. So once we're down to almost done, I might switch out to a new one. Now, I don't know if you guys saw it, but that's the reason I'm using a worn out cutter. I knew there's going to be trouble, so you'll note it's gone. I didn't have clearance. So just have to trust that things aren't going to move. Alright, so that was the last pass. Looks pretty good. It is pretty much exactly to size, so let's get around the other side. 0.1 of a millimeter to go. Alright, that's the end done to length. Next big job is bore it out. Okay, let's start bringing this out to 90 millimeters. I've got a hard stop set. Hang on. So I've got a hard stop set. I've got a mark on my boring bar which is at 35 millimeters. And once we've got it down to that and out to 90, we'll face off the bottom to give us the 36 millimeters. Flip it in the chuck, and then we'll tidy up the outside small end of the hole, which basically just needs a tickle up just to get rid of the saw marks, and a chamfer. And then all we need to do is the ends. So let's get cracking. Now I'm working in back gears because this is pretty big. This is going to take a while. How about I bring you guys back when I'm just a bit closer to that 90 millimeters? Because we should be about 68 at this point. And it's a long way to go. So we've got we're about 8 millimeters. We've taken 8 millimeters off the internal diameter, or increased it by 8 millimeters. Probably about another 8 to 9 still to go. Yeah, this is taking a while. Currently we have about 2.5 to 3 millimeters to come off the radius. So we're really close to having this bored out. We still have to bring it in about 0.5 millimeter or so worth of depth still. But we are really close to getting the die socket actually finished out. Then we'll have to flip it and just run a single pass down the inside, a little bit of chamfering, and then we're good to get back to the milling machine to do the holes. Alright, so we're at 87. Try and get another heavy cut out of it. We're 0.5 millimeter shy of our desired final depth. So let's do this. It should take us out to 88.5. So this is really close, like probably about 1/2 millimeter away. So increase speed. This is the fastest it'll go in back gearing, and we're doing a 10th hour depth of cut. It should be getting me about 1/2 millimeter off the diameter, and I think we're about 89.6 now. So this should be really, really close. And that's says 89.6. My guess was pretty close. Well, actually, it was exactly right on. So this will be 5th hour, which will take us out to about 89.9, and hopefully leave us a nicer finish. Let's get the speed down a bit, because I can't really see what I'm doing. So I'd like some more reaction time. I might do that internal chamfer a bit later, because I've got very little clearance in there. So let's flip it around. I'll just do a quick little. Okay. This is purely cosmetic. Alright, gearing up to drill. Oh, I've forgotten that. To drill the hole. For the end threads. Oh my god, this thing is heavy. So, our aim is to not exceed 43 millimeters in depth. Okay. Button oil and the brush keeps things clean. Okay, down we go. This is 3/4 inch. Can get that. And we're going down about 5 millimeters just to clear the shoulder. On the handle. Should do that. Okay. Now, for fun, none of my Imperial taps have a suitable center divot. So that little bit of a lead in actually helps to keep the tap centered. One of those. Well, I wish it kind of was on a was a through hole. Then I wouldn't have to clear the chips so much. And my power tapper only does up to 5/8 before the motor maxes out, which I thought at the time was going to be plenty. This is one of those. I wish I had a bigger one. I think that's about as far as that's going to go. Alright, so that goes in a millimetre. God, it's like a quarter of a turn. Okay, that's it, we've bottomed out. We will need to shorten them, the threaded portions, by probably, no, 2 or 3 millimetres, I guess. Okay, let's drill for the locking screws, or the locking grub screws, whatever. So these are at 90 degrees to each other, which is a bit odd. Usually there's 3 on one side and 2 on the other, but there we go. So, plus these are through holes, so nice and easy. All right, we're done. For comparison, you can't see it, but that's a 1-inch die holder in there. It is only just marginally longer than the body of this die stock. It's been challenging, it's been fun, and I'm looking forward to getting some use out of it in the very near future. So probably in a video or two you will see me using this to make a split nut for the letterpress slash book press that I'm building for my partner. So look out for that. If you've enjoyed this video, feel free to share on social media, and don't forget to hit the like button. Really helps the algorithms. But above all, I'd love it if you hit that subscribe button, and when you do, don't forget, ring the notification bell. So that's what I'm going to leave off. Get out to your shop, push your envelope. This certainly pushed mine. But above all, stay safe, and I will catch you for the next one.